Hello, so we have another question here, and actually the first part of this question is about volumes of solids of revolution, which is no longer in the spec for single maths, but is actually in the spec for further maths. Now, that's why I'm fine. If you skipped A, that's absolutely fine, and I'm actually going to sort of like do it by telling you there's a formula you need. I'm going to describe a volume of revolution as well, but there's a formula you need to come up with that result, and I'll show you the formula and then we'll derive the result. But you can do part B, because part B is just asking you to integrate this, and that is certainly something which you would be possibly expected to be able to do. Okay, so let's actually go about this then. How should we do this? So let's scroll down a little bit. Let me just say firstly that a volume of a revolution is the following. It's for any curve, and in this case we've got this curve, but it would work on any curve. If you've got to find that volume, well, if you ask to find a volume of revolution here, what I mean is if you rotated this, think of this coming outside of the page and rotating round. If you rotated that 360 degrees, you'd form like a bowl, a pointy bowl like that. Well, it's asking for the volume of the pointy bowl that would form. Yeah. Now, I'll show you a proof of this formula, but essentially when it's done parametrically, you use the formula pi y squared dx by dt dt. And that's the formula I'm going to use to try and solve this problem. So let's just write it down again. Pi y squared dx by dt dt, and it's that's using x limits as well. X equals a, x equals b. Okay, in our situation we've got y is tan t, I believe. Is that right? Y is tan, x is tan t, sorry, and y is 2 sine squared t. So let's write that down. X is tan t and y is 2 sine squared t. Now, if we follow that formula somewhat blindly, you'll see that we need to find dx by dt, and tan t differentiates to sec squared t. And then we're just going to plug in the values in our formula. Now, it wants to go from root 3 to 0. That's where it wants to revolve around. Y squared is simply going to be 4 sine to the power of 4t, and dx by dt is sec squared t dt. Now these limits are still in terms of x, so I really want to convert them to being in terms of t. And I'm also going to chuck the 4 out because it clearly starts with a 4 pi, so I might as well do that now because that's easy to do. Now to convert from x to t, we're going to use this equation. If x is root 3, well, arctan of root 3 is pi over 3. And arctan of 0 is 0. So we get the limits the same as what they're given in the question as well now. And then we've got this. We've got sine to the power of 4t. And then sec squared t is 1 over cos squared t. So I'm just going to write it as over cos squared t dt. And then that gives me this. That gives me sine squared t over cos squared t. That's my tan squared. Times by sine squared t dt between pi over 3 and 0. And what does that give me? That gives me tan squared t times by sine squared t, but sine squared t is of course 1 minus cos squared t. Now we're actually almost at the answer now, because if I times tan squared t by 1, I'm going to get tan squared t. But if I times tan squared t by cos squared t, I actually get minus sine squared t. And so we get this interesting result actually, that tan squared t times sine squared t actually equals tan squared t minus sine squared t, which seems somewhat really weird, but that's the way it is. Now, for the second part, this is something you could be asked to do, and certainly it is something I want you to be able to do. So let's have a go at integrating this. Now, once again, it's about tricks. 4 pi between pi over 3 and 0, tan squared. The trick for tan squared is very different to the trick for tan. The trick for tan squared is rewrite it as 1 plus tan squared is sec squared. So tan squared is actually sec squared t minus 1. And then the trick for sine squared is to use double angle formulae. It's the same for cos squared. As I hope you know, cos 2 theta is 2 cos squared theta minus 1, but it's also 1 minus 2 sine squared theta. And you can rearrange this to make sine squared theta equal to 1 minus cos 2 theta over 2. And that will be much easier to integrate. So we're going to write that as minus a half plus cos 2 theta over 2. Cos 2t, sorry, over 2 dt. And now I can integrate this directly because tan differentiates to sec squared, hence sec squared must integrate back to tan. And then we've got minus 1.5, well that will become minus 1.5t. And then we've got plus cos 2t over 2, well that's going to integrate to plus sine 2t over 4. Yeah, and if you differentiate that, you'll see, yeah, it does differentiate back to the line above. And now we can plug in our values. Now, they do want the exact value, so you've got to be, slightly careful here. Tan of pi over 3 is tan of 60, which is root 3. That's minus 3 over 2, so that's going to be minus pi over 2, I believe, because minus 3 over 2 times pi over 3, it's going to be pi over 2. And then we're going to have plus, okay, sine of pi over 3 is the same as sine of 2 pi over 3, so that's actually sine 60, which is root 3 over 2, root 3 over 8. And then do be slightly careful, although actually they're all going to go to 0, because tan of 0 is 0, and 1.5 times 0 is 0, and sine of 0 is 0. We're going to end up with 0, 0, 0, but do be careful there, because sometimes that doesn't necessarily happen. And so we end up with, if we add the root 3 to root 3 over 8, we end up with 9 root 3 over 8. That's from combining these two terms, and then minus a pi over 2 on the end, and that will work for the final answer. We've left it exact. Hope that makes sense.